Hello once again, our most developed student. My name is Confident and welcome to the continuation of the grade 9 graphs. And in the previous lesson, if you recall, we did an introduction of graph sketching, and I showed you how to sketch the first one, and then also we went on to look at how to sketch such a graph. Now in this lesson, we are going to look at the sketching of these graphs. Now when we're continuing again to put the foundation back, remember when you are sketching graphs, there are two things. Here we're dealing with straight line graphs. All right, let me just make it clear. But now there is always something interesting with a straight line, so that you must remind yourself, if it's a straight let me write this part. If it is going to be a straight line, you just need to know that a straight line needs 2 points to connect them. So if I can have a point there and another point there, I can then have what? My straight line. You see that? So even when you're sketching graphs, you can actually use 2 points which are far apart from each other, and every other point, as I indicated previously in the other previous video, please check it, all the other points are going to lie on top of that line. Why? Because it is a straight line. All right, so that is the advantage of sketching a straight line. In as much as they're going to say, whether you're using a table method or whatever method, just know that 2 points which are far apart will give me the actual straight line. Let's look at this. It says compare the graph of y is equal to 2x, y is 2x plus 1, y is 2x minus 1. We want to compare them. We want to see what does the plus 1 here do to 2x, and then the minus 1 do to 2x. Yeah, are you with me? So now I'm going to have I'm not going to do the table method because of time on this one. I just want to show you the impact. We're going to do the actual table method here. So to save time, when I'm sketching these graphs, let's start with the y is 2x, 2x plus 1, 2x minus 1. Let me write them down. Y is equal to 2x. That's the first one. The other one is y is equal to 2x plus 1. And the other one is y is equal to 2x minus 1. Are you having this? So what am I going to do? I'm going to find 2 points which are further apart. You can use kind of a table method in a way. It's still the table method that I'm going to use, but I'm choosing only 2 points. Remember, this is your x, this is your y, and then I'm going to choose 2 points that are further apart. But what they also encourage is you can find 2 points like this. You say when x is equal to 0, and then when y is equal to 0. This can give you 2 points, but unfortunately in a case like this, if we are saying when x is equal to 0, so I'll have y, when I substitute, it's 2, where there was x, what must I put? I must put that 0, you see? So y is equal to 0. You see that? Again, when y is 0, what is x? So I'm going to say here on the second one, where there is y, it's 0 is equal to 2x. You see, when I divide by 2, I'm still getting x is equal to 0. So there is no change here. When x is 0, y is 0. When y is 0, x is 0. So you can see that sometimes it doesn't work. The x and the y is 0, but it will work on the other side. So for now, let me choose 2 points which are further apart. I can do maybe say when x is minus 3, and when x is, I can choose 3. You see, from minus 3 to 3, I think they are further apart. What about y? This is what you do. You say when x is equal to minus 3, then you're going to substitute in y is equal to 2x. Right, but you're saying y is equal to 2, but what is x? X is minus 3. Then you put a bracket and you say minus 3. This is called substitution. If you check with a calculator, it will give you -6. Right, and then you put here minus 6. You do the same thing when x is equal to what now? When x is equal to 3, it's positive. So you've got y is equal to 2x, and then you've got y is equal to 2 times 3, and y is going to be what? +6. You see? So we're going to use these points as the first one. So far so good. Let's move on to the other one. Here we are using the same way. we're using the same 2 points which we feel which you think they are just further apart. So you'll have your x and your y. So in here we can, let's just maintain our minus 3 and 3. Alright, so we are saying when x is equal to negative 3, what about y? Y is equal to 2x plus 1. So y is equal to 2. You put a bracket of 3 plus negative 3, sorry, not 3, please, it's negative 3 plus 1. Y is equal to, use a calculator or you can do it mentally, 2 times minus 3 is minus 6 plus 1. Y is equal to what? Negative 5. You can cross check that. You can do the next one. When x is equal to positive 3, y is equal to 2, you put your positive 3 plus 1. So y is equal to 6 plus 1, which is 7. So here you have 7, here you've got minus 5. Are you with me? So this is what I mean when I'm saying you are going to have to substitute any points. Guys, you choose any. It will give us straight lines. You're going to see what I mean. So you've got your x, you've got your y, you've got 2 points. Let's maintain that minus 3 and 3. Alright. So here we're going to say, if we do that, it's x is equal to negative 3, y is equal to 2x minus 1. So what is y? It's 2 bracket minus 3 minus 1. Verify this with the calculator, but you must know mentally how to do this. 2 times minus 3 is minus 6 minus 1. You add and return the sign, which is negative 7. The last one is when x is equal to negative 3, y is equal to 2 negative 3. Okay, it's positive 3, sorry, now it's not negative 3. Okay, let me just correct that. When x is 3, so it's 2 3, which is positive. Alright, and then minus 1, which is y is 6 minus 1, then y is equal to 5. Are you seeing that? So you've got a negative 7 here. If I just maintain that, it's negative 7 and a 5. Guys, with these I can draw straight lines. Here, join 2 points, and then we want to see the influence, as we said, of the what? Of the, when you're adding and when you're maintaining the sign. Okay, there's that. So look at this. I'm going to draw, I just want a space here nicely. So this is my graph paper, and here I'm going to draw my points. Remember, you have to draw, this is the Cartesian plane, and this is almost like the center. Alright, so this is my x-axis, this is my y-axis. Alright, so in my x-axis I'll call this my 1, my 2, my 3, remember, and then here it's 1, 2, 3 and 4. I think let's take it further here, because if you still remember, what was the highest value of y? Here you had minus 6 and 6, here you had 5 and 7, minus 5. So 7 is the positive high value. So which means I need to erase here and draw it further to say this is 1, 2, 3, 4, this will be 5, this will be 6, this will be 7. I should have used, even if I wanted 2, 4, 6 at 10, you know, it's still fine. But I just want to use the longer scale intentional so that you can see the importance of a single line joining 2 points. Alright, so here is also minus 1, minus 2, minus 3. Remember the Cartesian plane, down is negative. Minus 4, minus 5, minus 6, negative 7. Alright, it can continue. Remember, this continues further for minus 8 and stuff. So even here you have got 3, then you can have 4. This is on this side minus 1, minus 2, minus 3, minus 4. Now when you mark these points, you need only 2 points. I'll maintain for this first one, y is equal to 2x. It says when x is negative 3, y is negative 6. So I come here to say when x is negative 3, and then y is also what? Negative 6. So there is Remember what I said? There is -3 there, and there is -6 there. And this is the point where the lines are gonna meet. Are you with me? So that is the point you mark here. So I'm gonna mark that point as the first point here. Let me mark it with that because we're using that. So this is my first point. The other point, it says when x is 3, y is 6. When x is 3, so it's positive now. Look at this. When x is 3, you go up. Y is 6, you go there. See where the points are meeting? You do the same thing. When x is 3, y is 6, you come here. So with this, you can now draw. See, my line does not allow. So let me minimize this. I can now draw a straight line. Look at it. A straight line that joins these. Ideally, it's supposed to pass through. Don't end where the lines are kind of cutting each other. You can allow it to pass through. I'm just doing it because of my limited way of making it straight. You're allowed to do this, you see. Let me try. I think it's on top there. The line must be long. See, this is the line. I can bring it back if it's bigger. It's just that with being bigger, it doesn't fit. But this is the line, you see. So let's call this graph y is equal to 2x. That's the name of the graph. We move on to the next one. The next one is this one where x is -3, x is -5. Let's mark that. When x is -3, and I mean -3 -5. So you come to -3, you come to -5. You see where the lines join? That is the meeting point. That's where you mark that point. So -3 -5. So a straight line, guys, it needs 2 points. But of course, if they say table method, they're trying to get you into the process of sketching these lines, okay? Then when x is 3, y is 7. I'm using that 3 and 7 here. So you take this and say, okay, if I was going 3 up and then going 7 horizontally, you see that line where they cross, it's your point. So here it is. And you know what is a straight line? It's a matter of joining those 2 lines and coming up with a straight line. So in essence, the graph is going to be something like this. You see what is happening there? I hope you'll be able to pick up what they mean. Remember, the aim was, the question was compare or look at these graphs and kind of make a conclusion what's happening with this. So when I say, okay, before I do that, before I conclude, let's continue with the last one. The last one was there, -3 -7. I'm gonna mark it with something different. -3 -7. I think you can see there is -3, there is -7. See where they meet. All right. So guys, I think it's getting better for you now. -3 -7, and the other point is what? Is 3, 5. So it's positive now. It's 3. Okay, I moved that fast. I think you can see the 3 and what? And the 5. See where they meet. All right. So this is the point that you mark, and you also what? You join these lines together. So I'm gonna draw a line here. It's easier first when you join them like this, and then passes, of course, but I need to come and take this further. Now, if you look at these lines, look at them. You see, it's more like these lines. If you check carefully, oh, I forgot something. You know what I forgot? You need to label them. This is y is equal to, it was 2x minus 1, and the other one here, it was y is equal to 2x plus 1. You cannot draw a graph that you don't give it a name. It's a must. You need to label your graphs. Even here, your x-axis and your y-axis, it's a must. Okay guys, if you don't do that, you'll be penalized marks. So what I was doing was wrong. But look at this. It's like these lines are parallel to each other. You know the parallel lines? They are lines that will never cut or cross each other. It's like they are parallel. So what does it mean? It means whether you are changing from 2x, the center one is 2x. If you say plus 1, look, the moment you say plus 1, it goes up. This is the one. This is the plus 1 version. If you say minus 1, it goes down. So what does the adding and subtracting do? If you come back to the question here, the question says sketch and compare the graphs. So what are you noting? You are noting that as I say plus, this graph goes this direction. So if I say plus 1, it cuts at 1. If I say plus 5, it was gonna cut here at 5. You see plus 1, if it's plus 5, it was gonna cut at 5 like this, parallel but cutting at 5. Okay, let me do it like this. This was the graph. If I say plus 5, I'm gonna take this graph for you, this one, and then when I start moving it, you see, if it's plus 5, that's what this graph was gonna do, just like that. It was going to what? Cut at 5, just like that, you know. If so, this was plus 1. If I say minus 4, so it will be this graph minus 4, it was gonna cut at 4 like this. You see, so when you say minus, it goes this direction. You see that? And then when you say what? When you say plus, it goes this direction. Okay, this plus means it goes up, you see. But there is also something important. As much as we were changing here, okay, I made it too big. As much as we were changing to say plus 1, but look at the 2. The 2 never changed. We call 2 the gradient. That's why they are parallel. So these lines are parallel, and remember, parallel lines here, that's a statement you must remember. Parallel for parallel lines. Parallel lines equals same slope. Remember, what does the word slope mean? Slope means same gradient. Are you with me? Just remember that. If they are parallel, they've got the same slope. Are you with me? Now let's move on to something else. Here, it wanted us to compare these graphs, and you use the same concept here. Let me go to the next. You are using the same concept. Nothing changes when you're comparing these graphs. Here, compare 3x, 4x, 5x. Use the same concept. I'm not going to do this one. And then after comparing them, you use the same concept. You get two values. Remember I told you, you've got your x and your y. And then those values must be far apart from each other. Then you're going to join them. Are you with me? The one I want to focus on is E here, which says sketch the graph of this one. This one. It says sketch the graph of y is equal to minus 2x plus 2 using table method. So I want to answer that for you, because that's what they're going to ask you in an exam. And I don't want you to panic and think that it's something different. So use the graph of this. Let's write it. Y is minus 2x plus 2. Let me write it down. Y is equal to minus 2x plus 2. Am I right? Minus 3x actually. Y is equal to minus 3x plus 2. They say use the table method. So what you do, you come here, you draw your table, as many points, but remember the trick. 2 points are enough for a straight line. 2 points. So the aim is to use, of course, the table method. Allows you to get as many points as possible. Then you take those points, join them together. They must all lie on the straight line. If you see the points not lying on the straight line, it means you made a mistake. So you will have your x, you will have your y. You need to know how to substitute, guys. You need to know. So here, it's up to you where you want to start with your x value. Sometimes they tell you, for example, they can do this in an exam. They will say from minus 3 is less than or equal to x is less than or equal to 4. Let's say they wrote this for values of x, meaning start from minus 3 and end in 4. That's what it means. So you'll have minus 3, minus 2, minus 1. You see, one at a time. 0, 1, 2, 3, 4. That's what it means. But now, it will not give you the y values because you need to find them. So for minus 3, you're going to write y when x is equal to negative 3. So y is equal to negative 3 bracket negative 3 plus 2. So you use a calculator there to say negative 3, it's 9, 9 plus 2, it's 11. Then you have your 11 there. And continue when x is equal to minus 2. So y is equal to minus 3. Now instead of minus 3, you put what? Minus 2 plus 2. Okay. So minus 3 times minus 2, it's 6 plus 2. 6 plus 2 is equal to what? 8. You do the same thing. See, this continues. When x is equal to minus 1, y is equal to minus 3 minus 1 plus 2, which is y is equal to 3 plus 2. It's what? It's 5. You move on. When x is equal to 0, you see, I'm just doing that so that you can understand. When x is equal to 0, y is equal to minus 3, put a bracket, 0 plus 2. What is y? Y is equal to 2. You put a 2. But after some time, you'll start to see a sequence. For example, look at this. You can predict some of them. From here to here, what did you say? You say here, 8 from 11 to 8. It's more like it's 3. If you say 8 plus 3, you get 11. Even here, the distance is what? 3. Even here, but you are subtracting, it's 3. You are saying 5 minus 3 is 2. 11 minus 3 is 8. What about here? From here, if you say, if you are expecting a 3, you're going to say 2 plus 3, which is what? Which is a 5. See? But we can test it. We can test it. When x is equal to 1, y is equal to 3, 1 plus 2. What is 3 times 1? Which is 3 plus 2 is 5. You see? So you can predict plus 3, 5 plus 3, you get 8, 8 plus 3, you get what? 11, 11, okay, 11 plus 3, when x is 4, let's test that one for 4. X is equal to 4, y is equal to minus 3, am I doing this right? I think I was doing it really wrong. It's supposed to be negative actually. Am I right? We will check this. Minus 3, 4 plus 2, so y is equal to minus 3, 4. This is minus 12 plus 2. Y is equal to negative 10. I think we're getting things wrong here. Let me actually erase this. I don't know why I was doing this part, but you'll see what I mean. The 3 will still be maintaining. It was not supposed so 2 minus 3, it was supposed to be minus 1 here. You're going down. It's 11 minus 3, it's 8. 8 minus 3, it's 5. 5 minus 3, so we are saying minus here. See, 5 minus 3 is 2. 2 minus 3 is minus 1. Minus 1 minus 3 here, you'll get minus 4. Minus 4 minus 3 here, you get minus 7. Minus 7 minus 3 is minus 10. So let's correct this. Let's correct this. This was when x is equal to 1. Here I wanted to say minus 1. So 3 minus 1, which is minus 3 plus 2. I don't know what I was doing, but it's fine. But here, if we put minus 1, which is minus 3 plus 1, which is negative 1. But this is correct. This is fine now. When you have done this, I can now say, of course they will need this. Sometimes they give you this table. Don't erase it. It's part of an important working. But for me, I don't need it. I was just trying to show you how this relates back to what you did. Then from here, what do? You can sketch the graph. You come here and then say, okay, I'm going to sketch a what? A straight line graph. Are you with me? You see, you look at your values for x and the values for y. So it's not a problem. We will start. Let me see, y goes to 11 and then y goes to minus 10. So you can see that you need a lot of y values. So if you start down on top there, see that you'll need quite a lot of y values. Alright, so if this continues like this, alright, so if I do that and then I do this, I hope it is gonna be enough for my y to be 11. Yes, I think this will be enough. The x values are not a problem here. You can see actually x starts from -3 to 4, so I can call this point, okay, every 2 squares. Look, every 2 squares I call it 1, every 2 squares I call it 2. I want to fill my graph. Every 2 squares I call it 3, every 2 squares I call it 4, then here is gonna be 5. Do the same thing. Every 2 squares is -1, every 2 squares -2, -3, -4. Are you with me? But because y is very long, I'm gonna take it one by one. So this will be 1, 2, 3, 4, 5, 6, 7, 8. Let's use 2 actually for y. It will be 2, 4, 6, 8, 10, 12. Still fine, because it was going to be too long. Okay, if your graph is not enough, try another scale. So which is -2, -4, -6, -8, and what, -10, and -12. You see, you need to know how to do this. This is the Cartesian plane. So when I've done this, I can put my arrow here to say these are my what? We call this the what axis? The y-axis. And then what do we call this horizontal axis? The x horizontal. It means x is 1, x is 2, x is 3. You still remember that? Now, if I have a point to plot, there it is. When x is -3, y is 11. So I come here and say x is -3. Okay, so you have a line there. There is x is -3. Y is 11, but 11 is not sure, but you estimate it like this is somewhere there in the center. You see, it's not gonna be very accurate sometimes, but it's important that you estimate. So you're like, okay, my 11 is there. All right, and then you move on. When x is -2, y is 8. Okay, 8 at least lies on the line, -2 and 8. There it is. You mark that. Very important on your marking. When x is -1, y is 5. You have got -1, now 5. You see, 5 is in between there. You can estimate it. Okay, so -1 and 5, it was like this. Are you seeing that? So let's do the right thing and mark it -1 and 5. Remember, it's supposed to give us a what? A straight line. And 0, 2. When x is 0, now don't get this confused. When you're saying x is 0 lies on the line. This is x is 0. This is x is 0. This is x is equal to 0. Now, when we're coming to this part of this one, x is equal to 0, y is 2. Look, this is x is equal to 0. It's along this line, vertical. X is equal to 1, I told you. This is x is equal to 1. This is x is equal to 2. If there's draw a line of x is equal to 5, this is it. Then you write it. X here is equal to 5. Are you with me? So don't let these lines confuse you. Okay, so I'm gonna take this off. So if we're saying x is 0 and then y is 2, where is y 2? Y is equal to 2. This is y is equal to 2. See where they meet? Where they are meeting, there is that point. Okay, so don't let it complicate things and get yourself confused. So x is 0 and 2. In essence, 0 and 2. It will lie on top of that x there. The next one is 1 and -1, meaning when x is 1, y is -1. Again, it's somewhere there. You see, it's somewhere there. You estimate 1 and -1 right here. They must form a straight line. Don't see some curves happening. 2 is minus 4 and x is 2, y is minus 4. This one is not difficult, it's somewhere there on top of that line. And then 3 and minus 7. X is 3, y is minus 7 is between minus 6, minus 8. It's somewhere there. Minus 7 is somewhere there. You see that? And then 3 is that. See where they meet? That is the point that you're going to mark there. So in essence, you're going to mark a point there. And then what do you have? You have 4 and minus 10. 4 there and minus 10 there. It will meet exactly there. Guys, this is what you have. And look at this. Look at the points. You will see, like, just that my space is limited, but I want to show you something. If I'm drawing these points, no matter how I try to run away, but you can see, because I was not that accurate, but look at them. They lie on a straight line. Do you see this? They all lie on a what? On a straight line. Then you label that graph and say y is equal to what? It was minus 3x plus what? It was minus 3x plus 2. We need to label it. Now, very important things I want us to do is to analyze. Let's analyze a few things about this. What are we gaining here? We use the table method, yes. Now look at this. When you see this minus 3, it means the slope of the graph is negative. Look at how it is. If it was plus 3, it was going to change and be like this. So whenever you have a positive, you get this. Where can I get that from? Let me show you. Let's go to the graph that we're plotting. You see this graph? We're getting 2x, 2x plus 1, 2x minus 1, but the 2 was positive. Look at the slope. So the slope, we say this is a positive slope. And the one that I've drawn here, we say this is a negative slope. That is very important. And then there is another one. Do you see this plus 2? This plus 2 is called the y-intercept. Meaning it is where the graph crosses. To intercept is to cross the y-axis. You are crossing y-axis. Alright. I just wanted to write this clear. Crossing the y-axis. So here you ask, where does it cross the y-axis? Now, which one are the y-axis? These are the y-axis. This one. So where does the graph cross the y-axis? You can see that the graph is crossing the y-axis there. That point, we call it the y-intercept. Are you with me? That is the y-intercept, where the graph crosses the y-axis. They didn't say it, it's not that they didn't say it, but it's not clear. There it is. What about this one? What axes are these? These are the x-axis. You see? And then we call these the x-intercept. Alright. But it's tricky. The x-intercept, I'm even here, you see, I cannot tell what it is. I can just guess to say maybe it's that is a half. It's more like, it's a bit difficult to guess there. But the y-intercept, you can see it's happening at 2. And the 2 you see is the same 2 you see in the equation itself. Even here, look at this graph that we drew. The first one was 2x. There was no intercept. You see, it cuts at 0. But when you start to say plus 1, let's look at plus 1. Look at the intercept of plus 1. Remember, it was this one there. And then if I'm to restore this graph, remember this graph, I moved it a bit to go back to the original. It was somewhere here, like this. It was like this previously. And then look at this. If I say minus 1, look at this minus 1. You see that's minus 1? It means the graph along the y-axis. You look for the y-axis because the y-intercept. Look. So this is the y-intercept. This is the x-intercept. To intercept means to cross the axis. So if I come here with a graph like this, for example, let me remove this. if I come here and draw and say this is my Cartesian plane that I'm giving you, this is my x, okay, and these are the x-axis. Just to wrap up, this is the y, this is the x, and then I say let's draw a graph like this. Now what are you going to conclude? We're going to conclude that this point there is along the x-axis. We call it the x-intercept, meaning it crosses the x-axis. Along the y, there is that point there. It's called the what? The y-intercept. All right, I didn't spell it right. And then look at the slope here. What is the slope? If it's sloping like this, you see it's going to the positive side. You see this is positive, y is positive, x is positive. This is called positive slope. All right, so here gradient is positive, is also positive here. Are you with me? So if I draw another graph, and this time the graph is like this, for example, there it is. It doesn't matter, it doesn't change. These are still the y-intercept. It crosses the y-axis, and these are called the what? X-intercept. It crosses the x-axis, but look at the slope. The slope here is negative. Why? Y here, I mean x here. Actually it was the slope. Don't worry with the y-axis on the slope. Always focus on the x. Look at it. X is negative. Here x was positive. So the slope has got to do with x only. So the slope here, we call this a negative slope. Okay, why is it called as negative slope? Because why is it negative? Because it is having the gradient being negative. I don't know whether I'm answering there, but that is a negative slope. The way it is inclining, we call it negative slope. When you write your equation, that's where you write things like y is equal to maybe minus 2x, or y is equal to minus 5x. When you see this minus, it means the graph is like this. And then on the other one here, when you're writing them, you expect them to be like this. Y is equal to maybe 4x. You see, positive first. Or 3x. You expect positive numbers before. That's a slope. I'm just being general, but it's very important for your analysis. The last thing I'll put into your mind is that every time you do this, when you say x-intercept, put a bracket, just know here y is equal to 0. When you say y-intercept, put a bracket, you must know here x is equal to 0. Are you with me? So it also helps that when I give, for example, an example here, e.g., if I say y is equal to 5x plus 7, right? And then I say to you, number 1, what is the gradient? You're going to say gradient, all right, is equal to, you look for that number, that is the gradient, it's 5. Number 2, if I say to you, what is the x-intercept? X-intercept. Remember I said when you see x-intercept, you say y is equal to 0. Then you come here and you say y is equal to 5x plus 7. Now, since y is 0 on the x-intercept, you see, you start solving. That's now an equation. You don't have to use a graph. You can actually find the intercepts, meaning where they cross. Then take 7 to the other side. It's minus 7, it's positive, is equal to 5x. How do you get rid of 5? You divide by 5. There is the x-intercept. So x is equal to minus 7 over 5. What is this? It's the x-intercept. Number 3, how do you find the y-intercept? The y-intercept, you've got two options. That number 7 is just called the y-intercept. But I told you about the y-intercept also. When you say y-intercept, what must you write? You must say x is equal to what? 0. Just like in x-intercept, y is equal to 0. So you write that equation, y is equal to 5x plus 7. So we are saying when x is 0, 5 times 0 plus 7, you see that there is 7 coming. Y is equal to 7. You can spot it by looking at it like this, or you can calculate it like this way. It works. So guys, this is what I wanted to bring to you as we're looking at the sketching of graphs. This was a foundation on the graph sketching. I'll bring you also some similar kind of previous papers so that you can see how you can score. You definitely need to score marks in this section. It's not difficult. It's the beginning where you need to lay proper foundation here for your grade 10, 11 and 12. Remember to subscribe. Join me again in the next lesson. Thank you.